Alright, here's something that I came across that was really, really interesting, and I really think it should be noted and documented. This is my schematic of what I'm using, what electronic parts I'm using in my window motor that I made. This is your basic SSG circuit with your 4007 diode coming across the battery, the plus and then the minus side. But I replaced it with a capacitor and made a small circuit using a SCR to pulse the battery once this capacitor gets up to a certain voltage, and the voltage is determined by the Zener diode here, but I have no idea what the value of this is. I took it off of a power supply somewhere, and it somehow worked perfectly. Another thing was this, in the original schematic where I kind of got this idea from, this was connected to the negative of the battery. But when I do that with this whole circuit, it would blow my SCR constantly. So when I did take it off, I noticed that the stupid thing worked anyways. So, okay, we'll get off of here and I'll show you the setup. Alright, so this is the setup. You have my window motor that I made right here. Hang on, let me zoom in slightly here. Okay, I'll walk over. Basically, it's just, I don't even know the number of windings. These are wires that I used off of a ceiling fan that I took apart. But it's basically the insides of an old AC motor, the bearings, everything, and it just has, let me tilt it over maybe, the magnet on top, north facing, and the other one south facing. There's the Bedini circuit. Got your neon light. Let me see. I'll point it out to you. Little neon light, the 1N4001 across the emitter and the base of the transistor. 1N4007 coming out to, you probably can't see that, but zoom out. Alright, so it comes to my capacitor here, like in the schematic. Negative goes to the output of the Bedini coil. And the positive, I got an alligator lead coming down and back here. Zoom out again. The alligator lead goes in back here and comes out the bottom. And it comes to my little circuit containing the SCR and the Zener diode here. I'll zoom up on that for you. Here's the small Zener diode resistor. It's 500 ohms. I've got another 500 ohm across with the capacitor, 5 microfarad, and I'm not sure the voltage. I think it's about 50 volts across the base in the emitter of the SCR, and I got the power going into the anode of the SCR, and then it goes through, well, my amp meter first. I got a clip going through it, and goes back to, zoom out here, my battery right there. But originally, when I first did the window motor, was to circulate the hot air around in a room. I was using an 18 volt nickel metal hydride battery, 4.6 hour, and the damn thing didn't last very long, so I said there must be a way of improving it, and this is why I thought I saw, what's his name, Rick Fredish or Fredick or something, and he had made a type of cap pulsar circuit, basically like this, but with a capacitor, and I wasn't sure if it was with a SCR. All I found was stuff that was basically using a 555 timer chip, and I didn't want that. I wanted as soon as he gets to a certain voltage, just dump it back into the battery. Anyway, my 18-hour, 2.6, what is it? 2.6 amp hour battery lasted for about 4 hours, and the window motor stopped blowing air, something I didn't want. So this is why I came up with this little circuit here. Let me get it going, and I'll show you amp measurements and everything. Hang on. Alright, so here it is basically. Here's my little window motor. I forgot to mention also, it's only a bifilar window motor. There you can see the magnets on top. There's one right there. And north-south arrangement, not north-north. Like, I don't know, I've seen a couple of them on the net. They had them all north, but Bedini said north-south on one of the schematics that he had. So there's the window motor. Here's the Bedini circuit, or SSG circuit. Here's my charging capacitor. This meter will be measuring the amps that are going back into the battery, right here. And this amp meter, up here, analog, will be measuring the amperage going into the motor. So I shall start it up. Should turn this on too. Alright, so I spin the thing and nothing happens. Turn the other meter on. Let's try this again. Alright, so this is the setup. Here's my window motor. Forgot to mention that it's just a simple bifilar. Like I said, I'm not even sure about the gauge. It looks to be like about 26 gauge, something like that. Here's the magnets. You can see north-south arrangement. Here's the SSG circuit there with the neon bulb going to my capacitor, and the output of my capacitor going through this little red guy in back, coming out through the front, and goes to my little SCR circuit with the Zener diode. Then it goes through this white lead. That's the base of the SCR, a base, or is it a gate? No, that's the anode or cathode, something. Anyway, it looks like a base. Anyways, here you go. Goes to this amp meter here. Measures how many amps that are going back into our battery bank. These are a bunch of resistors just to check to see different resonant frequencies. Anyways, you'll see. The next one here, this lead here, wait, show the people the lead, goes up to this analog ammeter, comes back down and powers the power coil of the window motor. So let's give it a turn here. Now if you listen, or even just look at the needle, it's going up and down. I don't know if it's going to capture this, but it's going really fast. It's oscillating. If you listen also, you can hear it. It's dumping back into the battery. You hear it? Duck, duck. So it's actually pulsing it, and you can see it on the ammeter here. Every once in a while, it's so short, it's having trouble capturing it, but I've seen pulses of 150 milliamps. Not doing much now, but there was a 70. So I figured, let's see, how much is it taking? It's pulsing also. I can zoom in on it, I think. It says about 50, 60, 70, 70. It's going up to the 80, say it's 80 and it's going up to almost 90 milliamps. So, not exactly. I suspect that the battery would last a lot longer. You know, I'm taking the radiant energy, transforming it back into regular electricity, and then going back into the battery. The way it looks now seems pretty good. But what happened was I made a mistake, and the whole thing started, like, I was adding onto the resistance. Now watch this, hang on, I'll set it up for you. Alright, so now I've added, like, I think they're about 500 ohms each, so that's 4,000 ohms across this. Oh, there goes my computer. So now, when I put the lead, turn it back on, you hear a little tiny oscillation. Now I look at how much milliamps it's taking at this oscillation, and it's like taking 10, 20 milliamps there. But look at this. I'm putting out 64 milliamps. Now, I did another mistake. I like doing mistakes. Watch what I did. Now, I made a mistake. I left this unconnected, and the damn thing still oscillated. So I said, well, I wonder what would happen if we take this switching mechanism, SCR that I was fooling with, and we'll throw that away. And then what I want to do is connect the amp meter directly from the output of the capacitor. Like directly, no minus again. It's like just having one wire going to the positive of the battery. And lo and behold, when I connect it, I get an oscillation. You can hear the oscillation. Here's the amp meter. I'm down to 10 milliamps right now. And I got 61 milliamps. Well, isn't that interesting? Let's try something else. We'll turn it off again. I'm going to take the capacitor completely out of the equation. Take off the negative. This is how I can do it with one hand. Okay, well look, it's unconnected. This is the power coil for the power coil, one of the leads. Okay, I'm gonna hang on. Okay, I'm taking the lead off the one of the power coil, the leads of the power coil. Throw it out of the way. Watch this. All I'm gonna do is I'm gonna even take off this capacitor. Just leave that connected as if it's going right into my, well, it is going right into my multimeter, and then going back into the battery. I'll come and get this thing again. You guys didn't see that, eh? Look. Capacitor, okay, multimeter goes into the multimeter and out back